Welcome to part 2 of Implicit Differentiation. In this video we're going to solve two more examples of implicit differentiation. So let's say that we have this equation and we want to find y prime. So as in the first example, we apply the derivative to both sides of the equation like this. Remember that this symbol means that we're taking the derivative of whatever is inside the brackets, and the same here. So we can separate the derivative here in the left side in these two terms, and in this term here we have the product of two functions. We have 4x squared times y, and in implicit differentiation we always consider y as a function of x. So here we need to apply the product rule, and this term here is y prime, what we're looking for, and this term here is, this derivative is very easy to find, is 3x squared. Now let's apply the product rule for this term. Applying the product rule, we have 4 times the derivative of x squared, that is 2x, times y, plus 4x squared times the derivative of y, that is y prime, minus this term here, that is 5y prime, equals 3x squared. So we have this relation here, and from now on we only need to solve for y prime. From now on it's just algebra. We factor 1 y prime, we subtract 8xy to both sides, and then we can solve for y prime. Notice that, well, here is the expression for y prime. Notice that we have y here, and in the case when you are solving problems involving implicit differentiation, you can usually leave the answer like this. There are some cases that you can solve for y, find y in the original expression, and replace that, but there is not usually a requirement. You can leave it just like this. So let's solve another example. The more examples you see, the better. Let's consider this equation. Here we have this equation. Here the exponent is 2 over 3, 2/3. So let's find y prime. What we do is to apply the derivative to both sides. In the right side here we have a constant, so the derivative of the constant is 0, and we can separate the terms in the left like this. Now in this case we need to apply the chain rule, because we have two composite functions. In the first term we have 2/3 times the x to the 2/3 minus 1, plus, and here we apply the chain rule again, we have 2/3 times y to the 2/3 minus 1. Now that was the derivative of the outside function, and what is the derivative of the inside function? The inside function is y, so its derivative is y prime, that equals 0. And here the exponent is minus 1/3, and the same here. And as this equals 0, we can divide everything by 2/3 and cancel them out, cancel this coefficient out. So we have this equation, and here we solve for y prime. This is very easy. We just subtract x to the minus 1/3, and let's solve for y prime. That's the final answer. That's all for now. Thank you for watching, and see you next time.